Okay, so in this lecture we're going to talk about complex rational expressions, and we're going to simplify these things using all of the previous procedures that we've learned, right? So multiplying, dividing, adding, and subtracting all combine to make more complex rational expressions that can be simplified, and these show up in many occasions, okay? So we're going to start out with some simpler ones and work our way to more complicated ones. The first example here, we have 1/6 minus a third, and then divided by 1/4 minus an eighth. So the procedure for this type of thing is, well, let's first simplify the numerator and denominator separately, and then we'll proceed from there. So how do we subtract 1/6 and 1/3? We have to find a common denominator, right? And the least common denominator would be a 6 in the denominator, because I could just multiply this by 2/2 to make a 6. Okay, what about this? Now, when you're simplifying the numerator, right, at this point I'm sort of ignoring the denominator. So let me just sort of show you that what I'm doing right now is independent of what we're going to be doing in the denominator. So that is a 1/6 minus 2/6, right? We're still going to have that denominator there. The reason I'm just showing you this is what's going on in the simplification is separate. So I don't need to make the denominator down here in common with the one up here. Okay, right now I'm just doing all this stuff separately. So now, how do you simplify the denominator? What is the least common denominator? Well, the least common multiple amongst these two denominators would be 8. So I could just make this an 8 by doing the same trick, 2/2 minus 1/8. So that'll be 2/8 minus 1/8, and then now it's much simpler to get a nicer denominator and numerator, right? So this will be 1 minus 2/6 divided by 2 minus 1/8. So that is -1/6 divided by 1/8. Okay, now here is where we're going to have to use what we have seen before, which is if you have a divided by b divided by c over d, that's the same thing as a over b divided by c over d. And how did we do this? Well, we multiplied by the reciprocal. So a over b multiplied by the reciprocal. Okay? So that's what we're going to do. We are going to have -1/6, and then we are going to multiply by the reciprocal of this. So that would be 8/1. Right, the reciprocal. So swap numerator and denominator, that's the reciprocal. So we have -8/6, which we have a common factor of 2, so we can reduce this actually a little bit as -4/3. Now continuing to examples that have some variables involved, the procedure is going to be identical. So first, how do we simplify the numerator? Well, we need a common denominator. So this is missing a y, so we're going to take the 1/x, multiply by y/y. The 2/y is missing the x, so we're going to multiply by x/x. Okay, now simplifying the denominator. Again, all of this simplification for these two are independent at the moment, right? So 2/x, it's missing this y, so we're going to multiply by y/y, and then plus 1/y, it is missing the x, so we'll multiply by x/x. So what do we have? Numerator is y/xy and plus 2x, and then we're going to divide by 2y plus x over xy. Okay, now the trick again, if you have fraction divided by fraction, is take the top fraction, the y plus 2x over xy, and we're going to multiply by the reciprocal of the denominator, so xy divided by 2y plus x. And here we see some reduction, right? The x reduces this x, and the y reduces this y, so we're left with y plus 2x over 2y plus x. And it doesn't look like there's going to be any reduction there, so that will be our answer. Moving on, down here, well, at this point, we just have a fraction divided by a fraction. So one thing we could actually do at this point is we can do this whole top fraction, the 3x plus 1 divided by x squared minus 49. And then we're going to multiply by the reciprocal of the whole fraction in the bottom. So that'll be x over 7 divided by 9x squared minus 1. Now, just like we had before when we were multiplying rational expressions, we have to factor in order to simplify. So the first one is 3x plus 1 times x minus 7. And what can we do down here? Well, that's a difference of squares, so that's x plus 7, x minus 7. This is a difference of squares. This is 3x squared, and that's 1 squared, so this is going to be 3x plus 1, 3x minus 1. And do we have any reduction? Well, yes, the 3x plus 1 reduces, and the x minus 7 reduces, so we are left with 1 up in the numerator. Both of these factors are gone, but then we have x plus 7 and 3x minus 1. What about our next example? Well, now we have 4 minus x to the negative 2. So what is that notation? So here is something important. When you have x to the negative n, this is the same as 1 over x to the n. Why is that? Well, that's because x to the negative 1 is just notation for 1 over x. So if I had x to the negative n, that's actually the same thing as x to the negative 1 to the n, which is 1 over x to the n, which is actually this right here. Okay, so they are the same. I'm just sort of simplifying them two different ways to verify to you that they are the same. So this is something useful to remember. So this is 4 minus 1 over x squared. And then down here we have 4 plus 4. X to the minus 1 is 1 over x. And then that's plus 1 over x squared. So rewriting this a little bit, so we have 4 minus 1 over x squared divided by 4 plus 4 over x plus 1 over x squared. Okay, now let's simplify the numerator and denominator separately. So what is missing in this fraction? Well, we don't have this denominator of x squared, so let's make that appear. We can make that appear by multiplying by x squared over x squared. And this already has the x squared, so we don't need to do anything. So that simplification will proceed. Down here, what's the least common denominator? So this fraction is missing an x squared. This is just missing an x. So we'll do 4 times x squared over x squared plus 4 divided by x times x over x. That's the missing piece, and this already is x squared. So now we have 4x squared minus 1 over x squared in that numerator divided by, and we will have 4x squared plus 4x, oops, this pen sometimes makes the 4 close and make it look like a 9, but it's like 4, and over x squared. And then now we have fraction over fraction, so we will do 4x squared minus 1 over x squared, and we will multiply by the reciprocal of this, so x squared divided by 4x squared plus 4x plus 1. And at this point we can factor and simplify. So what can we factor out of here? So this is a difference of squares. That's 2x plus 1, 2x minus 1, x squared. Well, these x squareds reduce. We could just get rid of those right away. Right, they're gone. And then this, does this factor? So this is 2x, let's try plus 1 plus 1. That looks good, right? 2x squared is 4x squared, 1, and then 2x plus 2x is 4x. So that looks good. reduces this, and we are left with the answer of 2x minus 1 divided by 2x plus 1. All right, what about the next example here? So this looks actually kind of similar. This is missing what's the least common denominator here? Well, this is missing an a and an a. So it's missing a squared. This is just missing one factor of a, and that's already a squared. So let's do 3a squared over a squared plus 5 over a over a minus 2 over a squared. That'll allow us to simplify the numerator. Denominator here, we'll do 3a squared over a squared minus 10 over a, and then we got to do a over a, so we get a denominator of a squared, and then plus 3 over a squared. Okay, so this is 3a squared plus 5a minus 2 all over a squared, and then divided by 3a squared minus 10a plus 3 all over a squared. And so we have fraction divided by fraction, so we'll multiply by we'll do this fraction, and then we will multiply by the reciprocal of this one. Okay, now that we've actually done this a few times, I can actually point this out to you, and you can see this here. If you ever get a fraction like this, where you actually have, you don't have to remember this, but you notice that that reduces. And so we immediately just have 3a squared plus 5a minus 2 over 3a squared minus 10a plus 3. So you see that you actually, this is actually a special situation. If you have, you don't have to remember this, but it's good to see why this is true. If you have a over b, and then you divide by c over b, so these actually have the same denominator, it is true that that's a over b times b over c. But look at this. The b's will always reduce, so you actually get a over c. So if you ever have a division of two fractions and they happen to have a common denominator, you will actually just get the ratio of the numerators, which is what we have. See, you don't have to remember that, because you could always do this intermediate step and it will just fall out. It'll just always happen. But it's good to see why that really is always going to be the case. Okay. In general, you might not have a common denominator like this, right? Remember before it was a d, so you might not get this reduction, but that's the procedure. I just wanted to point that out. And can we factor this anymore? So just kind of doing some trial and error here. We have 3a and an a, and we'll have a 3a and an a, right? To get a minus 2, we're going to have a 2 and a 1. One of those will have to be minus, but we're going to get a plus 5, so we need the positive to go with the larger. So it looks like we're going to have the plus 2, so we get a positive 6, and then a minus 1 to give us that 5. So is that right? 3a squared, and then plus 6a, minus a will give us a positive 5a, and then minus 2. So that looks correct. And to get the positive 3 and a negative 10, right, we're going to have both negatives to get a negative and a positive for the product. But to get this large negative, we're going to have the only factors of 3 are 3 and 1. So the 3 is going to have to go with the larger product, which would be here, and then a 1. So let's see if that's right. 3a squared, and then you see negative 9a, and then minus a will add it together to give us minus 10a, and then plus 3. Okay, so then we get this reduction, and we are left with a plus 2 divided by a minus 3. And now for our very last example, let's see what we can do here. So numerator, looking at these three fractions, we have a yz, xz, xy. So what is the yz missing from comparing to this? Well, it's missing this x. And then from this one, it would be missing the x as well. So it looks like we're just going to have to multiply this by x over x So it looks like the common denominator is going to be xyz. So if we have xz, we are missing the y. And if we have xy, we're missing the z. Okay, now what about down here? We have x squared, y squared, x squared, z squared, y squared, z squared. So this x squared, y squared would be missing z squared. And then looking at this one, it would be missing the z squared. So it looks like x squared, y squared, we're going to have to multiply by z squared over z squared, minus 1 over x squared, z squared. This is missing the y squared. And then the last one is missing the x squared. Okay, so now this is x squared minus y squared plus z squared divided by the common denominator of xyz divided by z squared minus y squared plus x squared divided by x squared, y squared, z squared. So we have the ratio of these two fractions, so it will be x squared minus y squared plus z squared divided by xyz, x squared, y squared, z squared divided by, so I'm multiplying by the reciprocal, z squared minus y squared plus x squared. And we can do some reduction, right? So one of these x's reduces, one of these y's reduces, one of these z's reduce, and we are left with x squared minus y squared plus z squared times xyz over z squared minus y squared plus x squared. Are these two the same? Well, look, it's x squared minus y squared plus z squared. So x squared minus y squared, z squared. So you see these two are actually the same. So we're actually left with just x, y, z.